Okay, so here's the circuit. I'm just going to go through all the different components so that when the video starts you can see what's doing what. The very first thing is the power supply on the left hand side. So that's just supplying 9 volts. It's a switching power supply, so relatively stable, but then I route the power through this LM317 and that can be set up to provide a different voltage through to the OpAmp for comparison. So the LM317, it's just got a 220 ohm resistor and a variable pot, and so then all you need to do is, with that variable pot just highlighted now, is to alter that, and that will change the power coming into the OpAmp. Then of course you need a way of measuring that, so that's just a little simple voltmeter on the side. It won't be measuring current, just volts, so you'll be able to see what's actually being fed into the OpAmp. As a reference voltage, there'll be 5 volts, so this is the 9 volts coming from the switching regulator, but then through a voltage divider that will be fed to the OpAmp as a reference voltage. The OpAmp itself has a couple of resistors which determine the sensitivity, the upper and lower boundaries of the Schmitt trigger, so that gives you a hysteresis. There's an LM358 in there at the moment, and finally there's an output which is fed via an output resistor to an LED. It actually goes via a transistor up there, and you can see the spare OpAmp ready to be switched in. That's actually an LM393 comparator. So that's the entire circuit. So now we'll just watch the video and see what happens as we raise and lower the voltage, and see what happens to the output. First up is the LM358, which should come on at 5.4 volts and go off at about 4.8. So here we are at 4.9, 5.1, so it should come on about now. There it is, 5.4, and then we wind it back. 4.8ish, it should go off, and there it is at 4.8. So next is the LM393, so with a narrower window between about 5.5 volts and about 5.2 volts. So we wind it up. There it goes, 5.5, and then winding it back. Should be about 5.2ish. And that's the circuit working. Good.